Hello students, in my last class we have done what is polynomials, the types of polynomials, depend on degree and depend on the terms, and we have also done what is zeros of polynomials. Now we will be doing exercise 2.2 from the question number 3 onward. We have done 1 and 2 before. So here what you're going to do, you're going to apply what you have learned, what is zeros of polynomial and so on. So let's start now one by one. This question number 3 from exercise 2.2. Verify whether the following are zeros of the polynomial. Indicate against them. Here what are you going to do is, you're going to replace the variable x with the given values of x. Here in the first question, the value of x is x equal to minus 1 by 3. This minus 1 by 3 you're going to replace on the polynomial and see whether the given polynomial is 0 or not. If it becomes 0, then the given value is the zeros of the polynomials. So let's start one by one, and I won't be doing all. I'll be choosing some of the questions from here. The rest you have to do as a homework. So let's start. Let's take the Roman number 2 question. P of x equal to 5x minus pi, where x equal to 4 by 5. You may think that the value of pi is 22 by 7. No, that is the approximate value of pi. Pi value is irrational, so you are not going to put any values of pi. You are going to put as pi only. So let's start now. Solution. P of x is equal to 5x minus pi. So putting the value of x equal to 4 by 5, P of 4 by 5, you get 5 into 4 by 5 minus pi. 5 cancel, you get 4 minus pi, which is not equal to 0. This is not equal to 0 because pi is not 4, so obviously it's not equal to 0. Therefore, x equal to 4 by 5 is not zeros of P of x. That is P of x. So like this you have to do one by one. I have done Roman number 2 for you, and I will be choosing one or two questions from the given questions. Look nicely. Now let's do Roman number 4. I have taken this question because there are two values of x. One is minus 1 and 2. You have to do separately. So solution. P of x is equal to x plus 1, x minus 2. Now let's put x equal to minus 1 first of all. Putting x equal to minus 1, then what you get here? P of minus 1. Instead of x, you have put minus 1, so here also you have to change it. Equal to, instead of x, what are you going to put? Minus 1 plus 1. Then here also, minus 1 minus 2. Then what you get here? Minus 1, 1, you get 0. Into minus plus, you get minus 3 inside. So anything multiplied with 0, what are you going to get? 0. So when you replace the value of x equal to minus 1, the whole polynomial becomes 0. Therefore, minus 1 is the zeros of the given polynomial. Therefore, minus 1 is the zeros of P of x. Likewise, you put the value of x equal to 2 and solve it. Let's do Roman number 6 again. Solution. P of x equal to Lx plus m. Here, the x is equal to minus m by L. So what you can do is P of minus m by L equal to L. Instead of x, you're going to put minus m by L plus m. L cancel. What do you get here? Minus m plus m, you get 0. Since the value of the polynomial becomes 0, therefore x equal to minus m by L is the zeros of p of x. Look nicely. Since the value of p of x becomes 0 when you replace x equal to minus m by L, therefore x equal to minus m by L is the zeros of the polynomial. It is. Let's take Roman number 7. Why I am taking up Roman number 7 is that because there are root 3. And the value of x is given minus 1 by root 3, another is 2 by root 3. You are going to do separately one by one. So, solution, p of x equal to 3x squared minus 1. Then p of, what I'm going to put is minus 1 by root 3 equal to 3. Instead of x, you're going to put minus 1 by root 3 whole square, because there's square here, minus 1. So what you can get is 3. Anything to the power, if the negative also, if the power is the even number, the whole thing becomes positive. This 1 square means 1. Root 3 square, you get 3. Minus 1. 3 cancel, you get 1 minus 1, you get 0. Here, don't confuse it. This is the power is even, so the whole thing will become an even number, means a positive number. Since the power is even number. So if you take the square of 1, you get 1. And if you take the square of root 3, you get 3. And 3 cancel with 3, the remaining is 1. 1 minus 1, you get 0. Therefore, what you have? X equal to minus 1 by root 3 is zeros of p of x. Next, let us do for 2 by root 3. So instead of here, you're going to put 2 by root 3. So what we have? 3, 2 by root 3 whole square minus 1. 3. 2 square, what are you going to get? 4. Root 3 square, what are you going to get? 3 minus 1. See, look nicely. 2 square, 4. Root 3 square, 3. Then 3 cancel with 3. We have 4 minus 1, which is equal to 3. And this is not equal to 0. Therefore, 2 by root 3 is not zeros of p of x. I hope you understand. Okay, let's do next. Let us see the question. Find 0 of the polynomial in each of the following cases. These are the linear. These are all linear polynomials, so it says 0 means a singular number. Okay, let's do one by one. So how to find the zeros of the given polynomial? Solution? Just put let 2x plus 5 equal to 0. Then try to solve the value of x. So what you're going to have here is 2x, transfer this 5 that side, you get minus 5. Therefore, x is equal to minus 5 by 2. That what you have the answer, minus 5 by 2, that is the zeros of the given polynomials. Here, minus 5 by 2 is 0 of 2x plus 5. One more thing I want to tell you is that since these are linear, means the degree of this polynomial is 1, then the maximum number of 0 it can have is only 1. If, for example, if there is a quadratic polynomial, the degree is 2, then the maximum number of zeros this polynomial can have is only 2. It may not have also, it may have or it may not have, but if it has, it will have at a maximum of only 2. And you can also have, for example, like this cubic. This is a cubic polynomial. The maximum number of zeros this polynomial can have is 3. It's not compulsory that every polynomial will have a zeros. It may have or may not have. But the maximum number of zeros a cubic polynomial can have is 3. What about the biquadratic, where the degree is 4? It can have at a maximum of 4 zeros. Let's do next question again. Here, the given polynomial p of x equal to ax and a is not equal to 0. There is no number, only variable is given. So let the given polynomial ax equal to 0. Therefore, x equal to, if I transfer this a this side, you get 0 by a. And a is not equal to 0. Therefore, anything divided to 0 except 0, you get 0. So 0 of ax is 0 because the value of x is 0. Next. Solution. Let cx plus d is equal to 0. We're going to find out the zeros of the given polynomial p of x equal to cx plus d, where c is not equal to 0 and c and d are real numbers. So let us put that this cx plus d is equal to 0 and let's find out the value of x. Implies cx equal to, if I transfer d this side, minus d, x equal to minus d by c, and this is the zeros of the polynomial. Minus d by c is zeros of p of x is equal to cx plus d. So look nicely. What are you going to suppose that the given polynomial equal to 0. Cx plus d equal to 0. Cx equal to minus d. When you d transfer on the other side, then x equal to minus d by c. This value of x is nothing but the zeros of the given polynomial. Thank you, students. I hope you understand the zeros of polynomial and how to find out zeros of polynomial, and do the rest of the question that I haven't done as a homework. Thank you.